Hi students, let's look at this question here, which was taken from the year 2012 paper 1 question 4 from the H2 math paper. Let's see how we can do this. This question is on Maclaurin series and power series. Alright, so let's see how. So you're given this triangle here with ABC, where the length of AB is given, that is 1 here, or unit length, and this is 3 over 4 pi. This is B, and and this is A, this is C. Okay, show that AC is equal to 1 over, so the first part is to show that AC is 1 over cosine theta minus sine theta, right? So let's try and show this. So the first thing is we try and understand how many lengths are involved. Usually what I'll tell students is this is AC, right? This is length here. We are given two angles, this angle and this, and we have another length here. Okay, so very conveniently what we could do is actually just try and relate them by using sine rule, right? Because we can actually express this. We have two angles and two length here involved. So here this length, this angle will be pi minus 3 over 4 pi minus theta. Theta is here. Right, so this case here will be pi, which is 180. 180 minus these two angle here. Alright, that will be 1/4 pi minus theta. That's pretty okay. So using sine rule, let's use sine rule. You need AC, so AC divided by sine 3/4 pi. This would be equals to AB, which is 1 sine the angle that we found just now is 1/4 pi minus theta. So this is 1/4 pi minus theta. Okay, that's pretty okay. Now once that is done, what we're going to do is actually just simplify this. So let's see, AB is 1 unit, so this is AC equals to sine 3/4 pi. AB is 1, and this value here is sine pi over 4 cosine theta minus cosine pi over 4 sine theta. Okay, just sine A minus sine B. So I'm just going to use the formula for sine A minus sine B. Right. So once it's done, I can just simplify this. Now 3/4 is a special angle here. It's actually sine 1/4 pi, which is 1 over root 2. But some of us actually forgotten our trigo ratio there. So what you can do is use your calculator and check the exact value. So I'm leaving in degree. I typically leave my Casio in degree because it is better. So you just need to change this to radian. So 3/4 times 180. Okay. So this case here, you'll get this gibberish here. So what you need to do is just square it. When you square it, you get half. Okay, so in other words, this is actually just positive root 2 here. Okay, sine 1/4 is also 1 over root 2. So I'm just going to put this sine 1/4 is 1 over root 2. Cosine theta, cosine pi over 2 is 1 over root 2, and this sine theta here. Okay, so once this is done, you can see that actually all these, you can cancel this. So this will be root 2. 1 over root 2 cosine theta minus 1 over root 2 sine theta. And that will be 1 over cosine theta minus sine theta. Okay? Proven. Shown. Sure, right? Shown. Yeah. Okay? That's how you do this first part, which is 4 marks. Now let's look at part 2. So given that theta is sufficiently small, so let's say theta is sufficiently small. Okay, show that AC is equals to 1 plus A theta plus B theta square. Okay, so this is important. So the first thing is you need to know that when it's small, let's say it's a small angle, let's say 0.01 theta. Right, so that's why T cube will be like negligible. 0.1. Theta 4 will be even worse, like it will be smaller. So this is like very close to 0. Not really, but in grand scheme of things is like very negligible. But anyway, the clue is you see that this tells you that ignore theta cube, okay, because it only expands on theta square. So that's the clue there. Now how do we then derive that? So from our standard series, we know that, so just take our standard series here, which is the standard series. We know that sine theta is x here. This can be ignored, okay? Cosine x theta here, which means we just need to ignore until theta cube. So this one we need to take square in, all right? So from the standard series, we know that these are the ones which are here. So we're going to do that by putting in when sine. So everything is just in the standard series, okay? So in other words, sine theta from MF 26 standard series, okay? Sine theta will be equals to x theta here. Sine theta will be equals to theta, and cosine theta will become 1 minus theta squared over 2. So become 1 minus theta squared over 2 factorial, which is 2, right? So in other words, from the first part, we know that we're going to use AC equals to 1 minus theta here. Cosine first, okay, 1 minus 2 minus theta, okay? So this is roughly equal. So what I did was I just sub this inside here, right? So once this is done, life is good. What we need next is essentially just change this to what do you call it? The inverse. I mean this form here, so that we can use power series. Okay, because this is not the form we need. We need it in ascending power as such, right? So we need it to be theta plus theta squared. It's a polynomial. So in this case here, is not a polynomial here. So I need to arrange this here. Now this is a power series. What we need is actually to segregate this. This is using 1 plus x n equals to nx plus 2 factorial. This is from MF26, right? So if you look at MF26, you have this power series here that you can use, right? So I'm going to use that over there. That will be great. So this case here, what we're going to get is actually just separate the x there. This is 1 minus theta. Okay, maybe I just put this plus theta squared over 2. Okay, so this case here, this is my x. This is my x here. So if I would use the power series, this will be 1 minus theta plus theta squared over 2 plus n, which is -1, -2 over 2 factorial, and I'm going to just square it. That's it. I can ignore the power 3 because I don't really need the power 3 there. So once that's done, we could just expand this part. It looks a bit complicated, but I think it's okay. 1 plus theta plus half over theta square. This will be -1, or this is plus or -1 because it's squared there. This will be theta plus half theta square. But because we only need the what do you call it? We only need the oh, this is positive, sorry. This is positive. -2 times 1, this is positive, this is positive. So we only need the lowest power. You don't need to expand everything. The middle term is theta square, theta cube, and theta power 4, but we only need theta square. So this case here can just ignore. So this is theta plus half theta square plus theta square. Okay, so that's how we do this part. This is 1 plus theta plus 3 over 2 theta square plus dot dot dot. Okay, there you go. So once that is done, we know that A is equal to, what is our A? A is actually the we just want a, which is this one here in front of theta. So 1 equals to a, and b equals to 3/2. Okay. Now this is how I do this questionnaire proficiently. If you have any questions or comments at all, please let us know. Keep practicing, and I'll see you in the next question.